Okay, today we're going to do some more fun with friction. We're going to combine it with your Atwood machines. Awesome sauce. So here's a fun one. What we're going to be doing is the classics. We're going to figure out what the acceleration is and then what the force of tension is going to be. Just like before, we have a 10 kilogram box, a 5 kilogram blue box with a coefficient of friction of 0.3. Thinking about the forces here, you have Fg. Fg is 98 newtons. You have a force of tension, which we'll worry about later. Here you have a force G, which is going to be 49 newtons. You have a normal force here, which is 49 newtons. And you also have a frictional force here. We'll figure that out in a second, and you're going to have a tension force right there. So we have to figure out what the force of friction is. So force of friction, in case you still haven't remembered, is equal to mu times your force normal. Since the force normal is 49, 49 times 0.3 is equal to 14.7. So now we can figure out what the acceleration is, because remember, F is equal to ma. Have you seen that formula before? So what's the force that's pulling on it? 98 minus the 14.7, because those are canceling out. Now the mass of this is going to be 5 and 10 together, so 15, and the A is A. So A is going to equal 98 minus 14.7 divided by 15, so 5.55. Nice, how about them fives? Meters per second squared. So there's our acceleration right there. Now we just have to figure out the tension. Well, which block do you want to do? I'm going to do the green one because whatever. So my net force is going to be ma. Alright, so let's just get that out of the way. Now the net force is going to be going down. It's going to accelerate downwards. So I'm going to do Fg minus Ft. Sound good? So I'll call downwards positive for this particular instance. So 98 minus Ft. M is going to be 10 times A is 5.55, so this is 55.5. Alrighty, so doing a little do-si-doseville, so 98 minus 55.5, and we are going to get a tension force of 42.5 newtons. Ta-da! We are so talented. Okay, let's do another one. This one, a little bit different. For the diagram below, the coefficient of friction is 0.0500. Find the velocity of the system and the distance the system moves in 3 seconds, starting from rest. Okay, so we're going to finally combine some motion into this. Alrighty, well, the first thing we're going to need is the acceleration. We're not going to need the force of tension for this one. I know, some of you were disappointed in the audience, but you could figure it out if you really wanted to. Anyways, let's figure out what the acceleration is. So we're going to have some forces. This one is going to be 30 times 9. Oh, see if you can pause the video to figure out the acceleration. 294 newtons. You should have figured it out by now. Oh well. 25 times 9.8 is 245. So 245, and this one is going to be 50. Wow, that's just going to be 490 newtons. And then we have a normal force here of 490. Now it's going to be moving to the right, so that means your force of friction is going to be going to the left. So we're going to have 490 times 0.0500 if you're so inclined. So this is going to be 24.5. newtons, if you want. Alright, so from here, what can we do? Well, let's figure out what the net force is. So F is equal to ma. Have you ever heard of that formula before? So we're going to have 294 minus 245, but that's not all that's pointed that way. We also have to minus the 24.5. Okay, and that's going to equal, all of them together is going to be 105 kilograms times A. So 294 minus 245 minus 24.5, enter. Hey, that's 24.5, how convenient. Divided by 105. So we're going to get an A is equal to 0.23233. Nice, so fun. Did you figure that out? After that, we have to figure out the velocity of the system and the distance it moves. Let's do velocity first, because that's easier. V is equal to V0 plus AT. That's V0, 0 plus 0.2333 times 3 is going to equal 0.7. So awesome. Meters per second. Now let's do distance is equal to d0 plus v0d plus 1/2 ad squared. So 0, 0, and then we're going to have 1/2 times 0.233 times t squared, which is going to be 9 altogether. Well, 3 squared, whatever. So 0.233 times 9 over 2, enter. So distance covered will be about 1.05, rounded that up, meters. So awesome. Hopefully you could figure it out. I think we got one more to do together. Alright, ramp it up. Does this look familiar at all? Wink, wink. If an Atwood machine is on an inclined plane with M1 is 14, let's write those down. How about that? So this is 14, and this is 7. This is 39 degrees. Coefficient, oh, it's a sticky thing, 1.06. Calculate the tension in the string, taking into account of friction, running against two decimal places. Alright, so we're first going to have to do the acceleration still. Anyways, go ahead, pause the video, see if you can do it. And once you unpause it, we'll see if you're right or if you're not. Okay, hopefully you've tried it at least. So we're going to figure out the forces first. 7 times 9.8 is going to be 68.6. So we have to split this one apart, right? So 14 times 9.8 is going to be 137.2. I'm going to have this guy and this guy, so the 39's in the right place. How about that? So let's figure out what the sine is. Sine 39 times 137 is going to be 86.3, and then the cosine version is going to be 106.6. Alright, so we know the normal force is 106.6, and we also need the friction force, right? Remember, mu times force normal, right? F is equal to mu times force normal. So the mu is 1.06, the force normal is 106.6, so multiply them together, and we're going to get a 113.0, so 113 is good enough. Okay, so these are all the force, well, except for tension force, right? Force, tension, force, tension. Okay, so let's figure out what's going down. Now, the system is going to be moving this way, right? Because the downwards forces are more than the upwards forces, right? Yes. Well, we don't have motion because this friction force will switch directions if we go that way. Okay, so it's going to be a static situation. All right? So we are not going to have movement, but that is okay. So A is going to equal 0. Tricksy, isn't it? Like those hobbitses. Okay, so what's going on, Mr. Keeney? How are you doing that? Well, here's the deal. So you've got your 14 block here, right? it's getting pulled down with gravity at 86, and it's getting pulled this way at 68.6, right? Alright, 86.3. Now, you'd think it'd be moving to the left, but it's not. The reason is because this is a force of friction, right? It's going to oppose motion, which means the force of friction is going to go this way. Now, the force of friction is never going to, like, push it and accelerate it. So the force of friction is just going to counteract this. Alright? So far, so good. So the force of friction is going to make it so nothing moves. So the force of friction is going to make up the difference. So that it's going to be 86.3 minus 68.6, and that's going to be 17.7 newtons. Alright, because that will make everything cancel out. Okie dokie. So what's the force of tension going to be? So the force of tension is going to be your 68.6, because it's pulling up this one at 68.6, so it's not moving, and it's pulling this way at 68.6 because 17.7 plus this is going to equal 86.3, and this isn't moving. So this is how much force the friction is actually pulling, because remember, this is the max amount. Alright, that was a fun problem. Not really. Hopefully you're doing okay with that. You're not going to see a lot of problems like that in this class, but I guess one snuck in, huh? How about it?